Hello, everyone. Welcome to our database series that will be taking place every first Monday of the month at 10 a.m. Pacific Standard Time, unless it falls on a public holiday. This session will introduce AI vector search in Oracle Database 23 AI, showing how to use vector data types, indexes, and SQL operators to build intelligent search features. You'll learn how these capabilities can enhance modern applications by combining advanced AI techniques with Oracle's scalable and reliable. Now, I would like to introduce Sean Stacy and Andy Rivenas as our main presenters. Over to you, Andy.
Great. Thanks, Ernesto. Hello, everybody. My name is Andy Rivenas. I'm a product manager with AI Vector Search. And in addition, we have Sean Stacy, who we will have both some description about how AI Vector Search works. And then Sean's got some really pretty cool demos to show you in action what happens with AI Vector Search. So Sean, you want to introduce yourself?
Yes, thank you, Andy. Hey, everyone. As Andy mentioned, I'm his co-PM with the database AI engine. And Andy and I have been working with AI vector search and many of this cool functionality for some time now. So let's get started. So today we're going to be focusing on AI vector search. And truly, this is the capability or the technology that makes Oracle Database 23 AI a vector database. But beyond AI vector search, Oracle Database 23 AI introduces a ton of new functionality focused on AI. And Andy can attest to the fact that there's a ton of other AI capabilities we've been extending the standard database to be able to support and to enhance your AI journey. Features such as annotations, extending our developer role to now have an AI developer role, extending external tables to support vectors. And just keep that in mind that what we'll be talking about today is just focused on pure AI vector search, but there's a ton of new functionality, some of which we'll be looking at as we go through this session. So probably the next question on everyone's mind is, okay, what is an AI vector search, right? So think of AI vector search as being a new technology that allows you to query digital information or information that's in your database that's not necessarily structured. It gives you the ability to perform a semantic search instead of a precise search. And you're using some new functionality using vectors to actually perform similarity search operations.
So, Sean, does that mean that I don't have to do our normal relational search any longer? I'm going to use AI vector search for everything, or how's that? How do I know which one to use, or do I even have to bother?
Oh wow, that's a good point. So I guess I did sugarcoat it a little bit too much, but yes, to your point, Andy, vectors are perfect for performing semantic search, and I'll explain what that means in a moment. But when it comes to performing a relational query, do we obsolete that now with the introduction of vectors? Absolutely not. So the relational model is perfect for exact query matches when you've got structured data and the precise match is desired, or in many cases, it's even necessary for your business. Now, moving on to how vectors work, right? If we look at their use and how they're implemented in the Oracle database, think of a vector as being a sequence of numbers or an array, if that's something you understand. And these sequence of numbers, each one of these numbers is called a dimension. And these numbers or these dimensions represent specific data points, important features of a digital object. And that digital object could be table information in an Oracle database. It could be an image or a photograph. It could be a video. It could be an audio file. It could be a document. And these digital objects get scanned or get run through an embedding model, passed through an embedding model, which generates one of these vectors. And many of these embedding models are trained using sentence transformers or neural networks or other techniques of deep learning models to generate or create these vectors.
So, Sean, so where can you get these embedding models, and how do you figure out which one you'd want to use?
Another good question. So these embedding models are available either commercially from vendors like OpenAI. Everyone's probably heard of OpenAI from Google, Cohere, Meta, just to name a few. Or they can even be downloaded. Open source versions of embedding models are out there. And probably the most prevalent location to download these embedding models are from Hugging Face. You can go into Hugging Face and download there's thousands of embedding models out there that you can use. And then we're also working with many companies today who are building their own embedding models, specifically in the biotech and pharmaceutical space. We're working with customers who are creating their own embedding models for generating vectors from very proprietary data, such as DNA sequences.
So is it one size fits all, or does the embedding model have like, do you do certain embedding models for certain kinds of data and for other types of data use a different embedding model? Is that how that works?
Another good question. So yes and no. So there are specific embedding models that are focused on the specific type of data. So as I mentioned, sentence transformers, they're predominantly used for when you're dealing with documents, right? Whether it's PDF documents or Word documents or just text files. There's embedding models like Blip or Clip for working with images, and there's some that are based on audio or video. We're also seeing, and I mentioned CLIP, we're also seeing inroads or new embedding models coming out that are multimodal in nature. So you can have an image and you can type a text string and it will find a description that matches to that image. So we're seeing a lot of new embedding models fall into that place as well.
Wow. Okay. Great. Thanks.
Oh, you're welcome, and I'll show some examples of that in real life in a moment. Now, once we've created this vector, this embedding for this digital object or this file, we now have this mathematical sequence of numbers, if you wish, which we can now perform distance metrics with, right? And in this simple example, we're using an out-of-the-box distance metric that Oracle supports called Euclidean squared, where we're subtracting the first vector from the other vector or the one on the right. But Oracle supports any number of these distance metrics, right? From cosine similarity is the most common one, Euclidean, Euclidean squared, dot product, Hamming, Jacquard, you name it. And most recently, we've also introduced the ability to write and roll your own distance metrics. At the end of the day, though, these distance metrics are based on the embedding model you use, and they go somewhat hand in hand. Um, so once you've created these vectors, it's possible for a computer algorithm to determine the similarity or the distance between these vectors. And I'll explain more about what that means in a moment. But before I do, I'll show you a use case of how vectors can extend an application. So in this little application here, we're looking for hiking trails with waterfalls, and we can take a sentence that we've entered, a phrase or a term, and we're able to pull up images and descriptions based on that term. And really, the power of what we're doing here really lies with a vector. And I'll show at the very end of this session a live lab that you can take and practice yourself, and you'll go through this exact data set and get to see this in play and how easy it is to implement this using SQL and nothing more than that.
So you can type in, oh, sorry, I'm just going
No,
to say
no,
you
go
could
for it. I'm
you
sorry.
can type in hiking trails and it figures out the from looking at the images and the vectors that have been created. That's just amazing. I think that's just phenomenal.
Oh yeah, and it gets even better than that, Andy. And I'll show you an example where I can do an image search based on a previous image. So it's very, very powerful. And the Oracle database has extensions to allow you to do this without leaving SQL if you choose to do so.
Amazing.
Right. So getting back to these vectors, then, if we look at our national parks example, right, we have this image of someone that happens to be walking on a hiking trail, and we have a vector to represent this image. And each one of these dimensions in this vector maps to a specific attribute or feature of this image, right? Like 33 tells us not only that it's a tree, but the type of tree that's in the image. The 42 tells us there's a bridge in the image. Now, you'll also notice that in this simple example, we're not saying pixel X 300 by Y 645 is green. We're actually describing what this image contains. And that's how we're able to perform these queries against these vectors. So they're an extremely powerful tool. Now, I will also point out I'm simplifying things here, and not all machine learning algorithms are as simple as we're seeing here. And to even dumb it down even more, I'm actually going to show you here a two-dimensional example to explain how semantic similarity works, right? So in this case, we've got a set of terms from strawberry, raspberry, blackberry, New York, elephant, cat, puppy. And we as human beings know that strawberry, raspberry, pear, and kiwi are fruits. And we know that New York, Texas, and California are states. And we understand that these other terms are animals. Now, where semantic search comes into play, and this is what vectors provide support for, is I could query my data set and say, find me the four closest matches to the term cat. And obviously the word cat is there, so I will find the word cat will appear. And next I will get returned kitten, lion, and puppy. And it's based on the distance in which those terms sit as they're related to the word cat. Now, I could also ask, or I could enter a term that's not even in this list of words, like the word tusk, and it would come back with elephant and potentially lion because sea lions have tusks, right? Or walruses do. So semantic search gives you the ability to perform those types of queries, and vectors are the tool that enables it to happen. Now, you'll also notice that we have terms such as apple that is somewhat closer to New York because there's a correlation between the Big Apple and New York. And kiwis are a type of bird, so you would see kiwis and animals would be somewhat closely related. And you might even find electronic gadgets that could be mapped to BlackBerry or Apple, right? But keep in mind, this is just a simple two-dimensional representation. Remember, the vectors that we have many more dimensions. And in some cases, you could have potentially vectors with 40,000 dimensions, as we've seen with some of our customers. So at the end of the day, vectors are all about allowing enterprises to extend business applications to use semantic search and enable semantic search to open the door to solving new problems, right? And we're seeing many customers solve some very different type of problems using vectors. For example, we're helping customers use retrieval augmented generation, which is where you can use a large language model, say OpenAI, but pass information from your Oracle database to help build the prompt to run that large language model query. And using retrieval augmented generation, not only does that mean that the large language model is up to date with information that's stored in your database, but we can also do this in a very secure way. I'm not going to go through every one of these examples, but we have customers today who are using vectors and AI vector search for solving these types of problems. And I'll give you an example of a visual search coming up in a moment. Now, I also mentioned that the number of dimensions that you can see in a vector could go to tens of thousands. To be honest, the vast majority of embedding models you'll see out there that create vectors will create vectors with maybe 2,000 dimensions maximum. But we are working with a biotech company that's sequencing DNA and storing vectors for that, and they're running over 40,000 dimensions. So the way that Oracle is addressing vector support in Oracle Database 23 AI is by creating, or we've released, if you wish, a new data type for storing these vector embeddings. And it's literally called a vector, and it can be defined as a column in a table. And I'll show you that in a moment, what that looks like. We've not only supported this new data type for storing vectors, we've also gone ahead and extended the SQL syntax to allow you to perform operations such as similarity search, these distance metrics between these vectors. And then to help with accelerating vector similarity search operations, we've added some vector specific indexes that can perform approximate search operations to help with working with vectors. And then the fourth piece we've added is this Onyx runtime library. And Onyx stands for the Open Neural Network Exchange. And basically, you can take an embedding model or a vector that's been created from an embedding model, wrap that with this Onyx wrapper, and then you can load that Onyx embedding model into the Oracle database and run your generation of these vectors from inside the database without ever leaving it. And we'll talk more about that in a moment. But keep in mind, these embedding models are not created by Oracle. They're created using industry standard or sometimes commercial grade embedding models to create these vectors. Now, the one last thing I'll point out is you'll notice that I've got the converged graphic here, Andy, and the reason being that vectors are treated as first-class objects within the Oracle database. So if you want to run a relational query against a vector or tie that to spatial or a property graph or a JSON document, go to town. We're actually encouraging you to do so. And with the converged database story, vectors can be worked upon and operated upon as you would any other component within your Oracle database without even leaving your Oracle database.
Yeah, so that's great. So actually, don't leave just yet. So we had a question, and I answered it, but it's worth pointing out here that the vector data type. So you don't have to have the actual unstructured data that you've created or generated the vector embeddings for in Oracle, right? You could have them somewhere else, and you could just store the actual vectors in the database. That's part of what the whole storing the vector embeddings. And the advantage would, and correct me if I get this wrong, but would be then all of the data that I have in my Oracle database can be used to supplement the search on the unstructured data, right? I mean, that was one of our questions. He said he had a fellow had, or one of the attendees has unstructured data in external systems and wanted to know if he could still use AI vector search with that.
Wow, that's a really good question, and there's a lot to unpack there. So first of all, to your point, there's actually, in my opinion, there's often more value in the vector itself versus the object, especially when dealing with images, right? Or it could be an X-ray or radiology image that's being stored as a blob in the Oracle database. That blob, other than being stored in a very secure, safe place, it's difficult to know how to compare that blob to another blob, that visual representation. But by storing the metadata of what that image contains, one could argue there's more value in storing that in the database. So yes, there's definitely a benefit in separating that object from the vector, and the vector itself, because of the math and the operations we can perform against it, as you'll see when we do a couple of queries later, there's much more value in it. Now, with respect to running or storing those vectors in external storage, yes, we do support that. We support even different data types such as Parquet if you're looking at using something such as Iceberg. So these vectors can be residing in object storage in another cloud or in Oracle's OCI cloud, or can be stored locally on a file system outside of the database as well. We're not preventing you from doing either approach.
Yeah, I think his main question was the actual data itself could be separated. And I think you have, well, we're gonna get to that. And when we talk about generating vectors, how you can, there's multiple ways to get the vector embeddings into the database, right?
Yes, absolutely. Yeah, and thank you for the correction.
Yeah.
Yeah, and I mean that leads me to the next slide, which is the functionality that you need to consider when working with vectors. So first of all, to your point, Andy, you need to create these embeddings. They're not just you store an object and all of a sudden you have a vector for it. You actually have to run the embedding model against the data to create or generate that vector. And we'll show how to do that in a moment. And we're going to drill through this, right, to generate them, how you would store them, how you can query them, because it's one thing having them stored, but really the power of being able to query them using SQL. And then the approximate vector indexes, we'll briefly touch upon that, and we'll talk about how we can integrate with the Oracle mission critical enterprise capabilities. So if we look at creating or generating vectors, it's a process where we convert this unstructured data using these embedding models And I mentioned this earlier, right? They're generated using deep learning embedding models, and these embedding models are available commercially or from open source. And Andy, you asked a question earlier, so I think we've kind of addressed this, but there is no best embedding model always for the problem that you're trying to solve. It's not like there's one size that fits all. Um, and it does make sense to evaluate a model, and we have some tools to help you do that. And I'll explain that in a moment when we look at how we store the embedding models. I'll explain a couple of things that can help you with evaluating them. So if we look at creating them, Oracle supports four approaches. The first approach is in answer to that question earlier about storing your vectors externally or your data externally. It's possible to have created these vectors using a service or an API to an external service and storing those vectors in a file system somewhere, or even having them in a data set that you load into the Oracle database. So vectors have their own format in terms of how they're created and how they're mapped to the data, the underlying data that they're that they're encapsulating. But the vectors themselves are independent to how the database represents them. So you can have these vectors created from another vector database, so to speak, copy those to a flat file, and then use those vectors in the Oracle database. As long as you know the embedding model, you can continue using them without having to convert anything. The other approach is to call these embedding models from the Oracle database. So we have a DBMS vector package and we have util to embedding, which allows you to call these remote services. So you could potentially call an embedding model from OpenAI, for example, pass your OpenAI key and call the embedding model to generate those vectors inside your Oracle database from this external source. The other approach is it's possible to create these embeddings in a middle tier. So I've got code that I run all the time where I'll call a Python program to create embeddings from data that sits within my Oracle database. And this is really useful when you have GPUs available to you and you've got this additional horsepower to perform these operations very efficiently. And then the fourth approach comes back to this Onyx runtime. With having this Onyx runtime engine running inside the Oracle database, it's possible to load an embedding model into the Oracle database and to run this vector embedding operation without even leaving your Oracle database. And this is extremely powerful for our customers, especially those that are in a space where they may be very sensitive about the security of their data and they don't want their data to leave their database to create those vectors from it.
So is there any problem? Can I mix and match the different ways to create? So say maybe I load a whole bunch of vectors in and then changes occur or I have new data. And then can I mix and match these different approaches?
Absolutely. So a good example might be where I do have GPUs available in my mid tier, and I've got terabytes of data that I need to create vectors for. I could run that initial pass to embed and vectorize my data. And once that data is sitting within my Oracle database, I could potentially then use these Onyx runtime libraries against any new data that I insert into my database, or more importantly, if I'm running any queries I want to embed my queries to match that vector that's been stored in my database. It's also possible to follow a data lifecycle process where I might want to age out some of my data and push that to external storage and potentially run embeddings externally on that external storage. So absolutely, yes, we do support operating upon them in these different formats simultaneously as well.
Great, thanks.
So let's move on to storing vectors, and this will come back. I'll revisit this whole concept of determining which embedding model is the best and where there are things that may make sense. Now, in this example, I have an image of a house, which is arbitrary whether or not I want to store that within my table, but I'm creating a table called house for sale, where I have the ID for the house row that I have. I have a price associated with the houses for sale. I have a city listed, I have a brief description of what my house looks like or what the details of the house for sale are. I happen to store the image of it. It doesn't need to be stored, but I can. But most importantly, I've got this column called vector, right? So the idea here is I want to be able to take an image of a house, take a photo of it on my phone, and vectorize that photo, and then look for similar photos that match the image that I just took. Um, Now, I'm showing you the most simple approach, which is where I'm not specifying the format of my vector, but it is possible to be more explicit in how I define that vector. So in this case, I can say, hey, it's got 768 dimensions, as we can see on the right, and it's a float 32. Now, be aware, Oracle supports float 32, float 64, unsigned in 8, binary, but the that format and the number of dimensions is dictated by the embedding model, right? So you want to be very aware of what that embedding model expects that vector format to look like. So if you are in the case of comparing one vector to another for its accuracy or performing similarity search operations, you may choose to go with the approach on the left, right? Where you can store any vector in there, any format, and it's just going to be loaded. Versus if you've explicitly defined what that vector is going to look like, you may hit some limitations. There may be restrictions when you try to insert these objects. Now, why you would choose to store your vectors in this format is, or with this strict definition, is because the Oracle database engine, if it knows the exact format of the vector that's loaded or stored, it can perform much more optimal, or I shouldn't say much more, but there'll be a subtle difference in performance when the Oracle database engine knows how to treat those vectors. And Andy, I want to bring up a point that you made a while back. We were talking about annotations and the issues you could hit when following that approach on the left and you're not strictly defining the vector. Did you want to comment on that one?
Yeah, well, that's a good point. Actually, I'm answering a couple of questions, which is great, guys. Keep the questions coming. But yeah, my question was, if you have to, if you're going to compare vectors, then they have to have been embedded with the same embedding model, right?
Yep.
Yeah. So then the question becomes, if I've got it in a table like this, um, how do I know what vector embedding model was, or what embedding model was used to generate or create the vectors? And so I thought that with the new feature of annotations, it was a great way to actually store the name of the embedding model right in for the column, house vector in your example on the vector data type, right? So then you know what was used.
Absolutely, and I've started adopting that behavior, so to speak, because especially in the mode that we work in, we're doing POCs with customers, and sometimes I'll use the same table, but just to compare different embedding models, and I may forget how I vectorize data, what embedding model I used, and it's an extremely helpful way to map and assign that information. Thank you for bringing that up.
Yeah, I think it's it's how do you figure it out? I mean, that's kind of how do you keep track of all this stuff? So I think the key here is that there's all sorts of tools in Oracle database that you can take advantage of. Um, and that's kind of the converged message, right? That we have all of all of these features we've built for the last, is it 30 years now, or is there more than that? It's probably longer than that, right?
Right.
Yeah, so
Yeah, it's a good point. All right, so let's look at how to search them, right? So using that house example, we've created our table with houses for sale, and we've got a vector stored there called house vector. Now I can pass a photo that I take from my phone and I embed that image. So I need a way of vectorizing that image that I've just taken. But in embedding it and generating a vector for it, I can then do an order by distance, right? Or vector distance. And couple of things to take into account here. First of all, I need to match whatever my vectors are stored in my table. I need to match that same embedding model for the photo that I've just taken. And this is where, so that needs to be accounted for. And that's where those annotations would be very helpful. The second piece is getting back to what you asked before, Andy, about having my vectors being embedded either in the database or in the middle layer or in an external location. This is where you would see the value of being able to perform these embeddings in different places. So perhaps the application I'm running on my phone to take the photograph and then embed that can perform the embedding. And then when it actually does the query to the database, it can pass that embedded vector for that distance operation.
Yeah,
Now,
so sorry, I'm going to interrupt you for just a second. So I'm answering a question that's about this, and the gist of the question was, do we have to load an Onyx model? Do we have to generate the vector in the database? But I see here you have a bind variable. So that bind variable could have come from what a like in your previous slide where you had the our choices, we could have just created a PL SQL function or whatever to go out to call an external middle tier application server to do the embedding and then pass that in as a bind variable, right? So you don't have to
exactly.
do it in the database.
Correct, correct. And I keep talking about the Onyx approach, but that is absolutely not necessary. That's just one approach. And there's reasons why you would choose not to use the Onyx wrapper. One of the most common ones is not every embedding model is supported with the Onyx runtime library. The nice thing about Onyx, though, is embedding models can be written in, or the utilities to generate the vectors can be written in any number of languages. And Onyx provides a simple framework that's standardized for running these models. But yeah, we could be running this as a standalone app to perform that embedding operation on my smartphone. It could be running as a Python program. There's many different ways to do that.
Great, thanks. Yep.
Yep. And then the other thing I'll point out is in running the query this way, I'm able to say, hey, I want to find the 10 closest images that match the image that I've just uploaded. So it's a very powerful way of performing this similarity search, so to speak. Now, the problem that you would immediately encounter is, well, this house looks Japanese, right? And what if I live in Atlanta? And what if this house is $20 million dollars and my budget is $100,000? Well, say $200,000 to be a bit more realistic. I'm going to be pulling back matches based on how closely they resemble this picture, but it might not be relevant to my specific search. And this is where the Oracle database engine comes into play because I'm able to filter out the data, hone in on just the information or those rows of data in my house for sale table that match the problem I'm trying to solve. So in this case, hey, I happen to be located in Atlanta, so I'm only looking for houses for sale in Atlanta that look similar to this image. And at the same time, I'm also able to say, hey, I've got a set budget. The budget is listed or is available in my customers table. So I'm doing a join against my customers table to determine the budget. And I'm only doing the similarity search or the distance operation between photos that match the photo I've uploaded, and those houses are in Atlanta and they're below my budget threshold. And we're able to do this with only 6 lines of code.
So you're actually running a relational query and a vector query, if you will, in the same SQL statement. So you got your where clause. So that's all traditional. Everybody, in Oracle database, that's how they run, you run a query. And then the order by because you're comparing the distance between vectors that are the most similar. I mean, the order by clause, then you wouldn't have like where vector distance equals. You do order by because you're what the set of can you explain that a little bit maybe? That may help
Yeah,
people out?
absolutely. And you raise a good point. So the power of having the order by is definitely the optimizations of finding all the rows and only just narrowing down what's retrieved. And I get a ranking, right, where I've got ascending order or descending order based on that distance between them. Now, to your point, if I had said where the vector distance for this image is less than a certain range, I could also do a similar type of query, but in many senses, it's not as powerful as what we're trying to solve here. But it is possible, to your point, it is possible to include that vector distance as part of your where statement. Because if you were to print that vector distance, you would get a number that would show you the distance between these two vectors. And therefore, we could say where my vector distance itself is less than, say, 100. But
But you
for
wouldn't really know what vector distance. Oh, I mean just the distance itself, but the meaning of that doesn't really make a lot of sense, right? Because didn't you say all the vectors are just these a bunch of mathematical numbers that got created by some model somewhere, right? So,
Correct, correct. So you would have to understand the model itself. And I'll give you one example where it might be valid to perform that type of operation. One might be where, hey, I care about the first 10 rows, but only when they're very similar. So I could put a very low scale of vector distance, which I would have to know what that is. And then the other example that we're seeing customers use for things such as fraudulent detection or fraudulent activity is for anomalies where there might be an outlier and they're looking for vector distance exceeding a certain distance. So it can be used in reverse.
well,
Um, yeah, it's pretty rare to see that. 99% of the customers I work with are using it in exactly the mode that we've got in this example. But yeah, I forgot about that. So thank you for reminding me. So you can see that creating a vector is not that difficult. I'll show you exactly what it looks like through a SQL view of the world. And querying it is extremely easy. If you've ever written SQL before, we bring that power to you. The next piece of the puzzle is actually accelerating these vectors. And one of the points that I should have made on that previous slide where I showed you that sample code is we are doing what's called an exact K or an exact match for every vector inside our table. Now, that works fine for a table that either two things, right? Either you don't have a lot of data to go against, or you have enough time up your sleeve to wait for the exact response. But in many situations, when I'm pulling up an app to look for a similar image on my phone, for example, I might be bound by time. And in many cases, an approximate search may be more useful for what I'm trying to do. And this is where vector indexes come into play. So Oracle has three types of vector indexes that we support. The first one is our neighbor graph vector index. And these are in-memory based indexes that are stored as graphs, with the vertices being the vectors and the edges or the arrows, if you're not familiar with graphs, the edges between the vertices is the actual distance between the vectors. And it's a layer of these graphs. Now, these graphs are most commonly known as hierarchical navigable small world indexes or HNSW indexes. It's an industry standard practice or type of vector index, and they're extremely efficient and extremely accurate. And when I say they're approximate, they're very close to perfect in terms of their accuracy. Now, the issue with neighbor graph vector indexes are they are memory resident, which is a good thing and a bad thing. And the bad thing being that they do occupy space. And there may be a situation where you may not have sufficient memory to accommodate your HNSW indexes. Now, keep in mind with Oracle, because we're storing these vectors in the database as first-class citizens, you can scale them using sharding or real application clusters or globally distributed databases, etc. But if you truly are at a point where you have petabytes of data potentially, and it's just impractical to load these vector indexes into memory, then Oracle has an alternative form of indexing called neighbor partition vector indexes, or otherwise known as inverted file flat indexes. And these are disk-based indexes. They're a little less accurate than the HNSW indexes on the left. However, they are extremely efficient at filtering out data and performing or retrieving vectors very, very efficiently. I'll also point out that these types of indexes are also, they're common with FAISS, for example, FAISS vector databases use this form of indexing. Now, the third form of index that Oracle supports is a hybrid vector index. And this is where we combine a vectorizer and a tokenizer. So we store this similarity search set of the data, and we also support the ontological mapping or the text or keyword maps of the data that's been stored in the database as well. And we combine the two. So you've got the best of both worlds in that you can run a query uh, running a similarity search for contextually looking for information that might be related to a set of terms, as well as some exact terms. So I'm working with, actually, I'm working with two medical facilities that are using Oracle Vector Search for storing and looking at patient information, but looking for perhaps anomalies where the patient may have an allergic reaction to a specific type of drug or pharmaceutical, and they're looking for semantic similarity for treating a particular ailment, but then also looking for a text-based search to say where they cannot take a particular type of medication. And one of the other things about these hybrid vector indexes is you don't have to create, those vectors don't need to pre-exist. You simply load your data and build the index on top of that data, and it will take care of creating the embeddings or vectorizing the data for you.
And I suggest this is the seems like a pretty complicated topic. Maybe you could point out to folks that we do have some blogs that they could go back and, if they're interested, take a look at with some examples we've worked um, in our in blogs.oracle.com, right? So,
Yeah.
because that's a lot of material. I'm just going, man, this is we could probably do a whole session just on this, don't you think?
Yeah, so just so you're all aware, that was a shameless plug by Andy. Andy has authored some brilliant blogs on these very topics, and I've learned a lot by going through them myself. So yeah, there's a series of blogs, right, Andy? And we do have a slide at the end of this session where I will share the links for those blog posts. But you can go in knowing nothing and come out knowing how to create the HNSW indexes, not only creating them, but seeing how to determine if you have enough memory and to set your system up to run with them, as well as creating the IVF flat, as well as creating the hybrid vector indexes. And Andy, what's the data set you used again for the hybrid vector indexes?
Oh gosh, you're gonna put me on the spot. I don't, we used the Chicago police was like the beginning. We used public data sets. So if you guys want to follow the blog and try this out for yourself, you can. You could do it in 23 AI free. But what did we use? Oh, Wikipedia. I think I used Wikipedia data
That's what
because
I thought. Yeah.
yeah, because it combined, the hybrid vector index, I don't know about the vectorizer and the tokenizer, but it combines, Oracle text search with Oracle semantic search. And so I describe in the blog, but yeah, I think we used a Wikipedia data set. And all of this was free. So I talk about it in the blog post how you can actually go try this out for yourself. So, but of course, I couldn't be misremembering, but I'm pretty sure it was the Wikipedia data
Yeah,
set for
I
that.
thought it was too.
Yeah.
And then you just I don't know how you reminded me, but you just did that the vectorizer to create the vectors, as I mentioned before, you point to the data, so the Wikipedia data set in Andy's case, and you create the vectors for them. Well, you can create your vector indexes as either HNSW or IVF. It lets you
Yeah.
do both.
Right.
And
You get a choice.
yeah, absolutely. And then also, you can have a combination of all of these indexes in place in your Oracle database. We don't force you to use one or the other. And it's possible to have a table with vectors in it, to have multiple indexes in place as well. All right, so I'm going to speed through the integration. I've kind of alluded to it already, but I'll mention one example where this has been extremely powerful. So because the vector data type is part of our converged database story, you can run your Oracle database with sharding, with partitioning, with transactions, with rack, and you can take advantage of those capabilities while storing vectors in your database. So a good example, if I talk to a customer that has three sets of types of data that their end users are accessing. One user base is highly confidential, another is top secret, and another is classified. And yes, they're in that category of data that they're storing in their database. And they had to create multiple vector databases to solve that problem. They're moving that data set to the Oracle database because they're able to use virtual private database and label security, i.e., traditional Oracle security capabilities can be applied to their vector databases to solve the same problem. And that way, they've only got one set of vector database sitting in their database, but they're able to apply these different realms or different types of security as it sits. If you have SOX compliance requirements or HIPAA compliance requirements or FedRAMP, you can apply that and your vector data is treated no differently to your relational data. And yes, if you're running on an Exadata, we've got special enhancements in Exadata to take advantage of vectors with AI smart scan capabilities as just one thing that we've added.
So
So,
I'm going to interrupt you just to, we're getting close. So that we got the demo because we only have, our time is starting to shrink on us. So I just wanted to let you know.
okay, sounds good. So I am going to reduce my screen and I'll show you really. Can you see my screen okay?
Yeah, I can see it.
Perfect. All right, is the font size okay? Actually, I'll make it bigger. There you go.
Looks good to me, but anybody in the chat, if you're having trouble, if he needs to make it bigger, just post a Q&A question. We'll take a look at it.
For sure. Thank you. So I'm making sure I'm connected to my database, which I am. And here I have I have an example, and I'm using Onyx in this example, where I'm going ahead and I'm going to query that national parks data set, the one with the hiking trails, for example. The first thing I need to do is create an access point because I'm going to connect to the public website, National Parks website that the government provides access to, and I'm accessing my Onyx model from my file system. This is how I load my model, DBMS vector load Onyx model. This is an Onyx example, right? It doesn't need to be done in the database, but this is how you would do it. I'm using All Mini LML12. I also happen to have ClipVit based patch 32 for images and for text. This is a multimodal model that's in place there. And then once I've loaded my model, I can query it. And you can see here's my models that I've loaded. Here's the format that they've been loaded, that they apply to. And I can also now I've gone in and I've created a park vector table that's based on my parks table, the description of my parks table. So the description looks like this. And I've gone ahead and I've vectorized that if you wish, and created a table called park vector. This is the syntax there. Now that I've done that, I can actually query my table. So I'm going to query my park vector table with the description, a search string. So I can put in there, let's say volcanoes. Sorry, I've got something in the way. There we go. Apply. And here I can see some things that have been returned. Now, the first one actually has the word volcano, so I'm kind of cheating there. But this next one, craters on the moon, I don't see the word volcano there, but that word crater and lava flows is related, is associated with volcanoes. So you can see how you can pretty quickly perform those operations. I can even use my clip base patch 32 to perform a query as well. And in this case, I'm looking for the word Sagoro, and it's brought up this link, which is a URL stored in my database, and that's what that maps to. So that's how I can do a similarity search quite efficiently. But I think a nicer example is a program I've written, or I used MCP Server to create, where I can type the exact same things again. So let's say vol volcanoes, and I'm going against the national parks website and the data that's available there. So here's some images that were stored in the database. I could say hiking trails with dogs. Whoopsie, can't type. And here's some images that have come up. So this is a pure vector search operation that I'm performing. And then one last example I'll show you because I am running short on time is I can actually upload an image and do a similarity search based on that image. So I've got some pictures here. I have a picture of someone riding a horse, for example. And when I query that, it takes a little while to upload the image. You can see the images it's queried are coming back quicker than the image that I uploaded being presented. I'm not sure what's going on there.
So we had a couple of questions about, gee, can all these things that Sean's talked about, can we do this in a live lab? And
Haha.
the things that you're showing are similar to what we use the national parks demo, right? And I think you have a slide that points to where it's at. Yeah. But the answer is yes. We have a getting started with Oracle AI vector search, and we kind of walk through all of the most of the things you've talked about, not everything, but almost all of it in general, all of the topics, and where you can try this out for yourself, right? So you obviously brought up the URL. So if you folks want to, you can either search on it or
No, no, take a photo with your phone and you'll have the QR code
oh,
there.
the QR code. Yeah, duh. Yeah,
Yeah,
good
jump
job.
straight to it as well. Yeah, and by the way, Andy's the author for that live lab as well. So Andy's been pretty prolific on publishing great content, but it is based on that national parks example. And we actually have an Apex app that illustrates the images being returned as well, doing the image query. So very powerful stuff. So we have the blog post that Andy has written. There you can see it's the same person. They're wonderful blog posts and they're extremely powerful in getting started and zero to hero, right, in terms of understanding this vector search capability. I'll also point out that not only do we have the live labs and that one that we just showed you, the getting started one, Andy mentioned the database free edition, either autonomous database or download and run as a Docker container or run on your own machine. And then we also have the AI Solution Hubs. And the AI Solutions Hub is really powerful for performing operations such as comparing different embedding models. It gives you a nice little sandbox to play around with different embedding models and to see, it gives you a two-dimensional graphic representation of how the data gets embedded, and it will plot it on a chart for you. And those are some of the things that are available without any installation of software required. We have a ton of additional AI vector search links for you to go and take a look at, including our vector search user guide. There's some very, very interesting data. It can go as deep as you want it to go in that documentation set. So Stan, I'll pass it back to you.
Thank you, Sean and Andy, for an awesome session today. We really appreciate your time and help. I hope this was a good experience for everyone. If
I
you
hope.
enjoyed today's session, and you would like to contact us for personal training sessions for your organization, do email us at our personal training email, and we will reach out to you. If you want us to conduct just a hands-on lab, we have our newly designed QuickShot Live Lab program for a more expedited hands-on learning experience for specific cloud topics. So under the Code Innovate program, we co-develop a solution based on your own use case. So please remember that personal training is an investment we make in our customers to help you grow and develop your OCI skills at no extra cost. So if you're interested in personalized training, please email us at that email below. All right, and here is our Day One and Beyond series and upcoming sessions for the month of October. You still have an opportunity to attend a couple more sessions this month with our hands-on series, our cloud security series, our core series, and our Did You Know and What's New in OCI. Now, our next database session will be on November 3rd. So in this session, you will learn about Oracle Database 23AI, how Oracle Database 23AI brings AI to your data using knowledge graphs, and how to start your account off correctly with best practices. So we do hope that you learned something new today. Thank you again, Sean and Andy, for today's session. Um, I hope we see everyone else at our next database session, and hope you all have a wonderful day. Thank you.